Okay, dear students, welcome to the next chapter, study of compounds ammonia. In my previous video, I have done study of compounds hydrogen chloride gas and hydrochloric acid. Today, I would like to discuss study of compounds ammonia. The important points, important things I'll explain you in this chapter. Now, as you can see on the board, I have written down the lab method of preparation of ammonia from ammonium chloride. The equation you can see, twice NH4Cl, twice NH4Cl plus CaOH twice, it is forming calcium chloride, it is forming calcium chloride and it is forming calcium chloride, water and ammonia gas. Now if you look at the equation very carefully, it is already balanced and we need heat energy. Dry ammonium chloride, it is mixed with slaked limes, dry slaked lime. Ammonium chloride is commonly called sal ammoniac, and this ammonium chloride and slaked lime are mixed in the ratio 2:3 by weight. Now look at the diagram. In the diagram you can see there is a round bottom flask. In this round bottom flask, we take calcium hydroxide plus ammonium chloride in the ratio 2:3 by weight, and this round bottom flask is heated from underneath. It is heated from underneath, and then the reaction starts between calcium hydroxide and ammonium chloride when ammonia gas is formed. This ammonia gas enters this delivery tube. It goes all along this way, enters this container, which contains dry quicklime. Quicklime is nothing but it is calcium oxide chemically. So this ammonia gas goes up in this manner. It enters the quicklime chamber over here, a tower which is packed with quicklime, and then ammonia gas comes out and gets collected over here. This is dry ammonia gas getting collected over here. Ammonia gas gets collected over here by the downward displacement of air. Now ammonia gas is lighter than air, that is why it is being collected by the downward displacement of air. The drying agent used to dry ammonia gas is calcium oxide. Okay. Now this is an important equation. This is the lab method of preparation of ammonia from ammonium chloride salt and calcium hydroxide, which is called slaked lime. There are other equations also for the preparation of this gas. This gas, like by reacting ammonium salts, any ammonium salt, you can see over here, with a strong alkali. Any ammonium salt with a strong alkali will always give ammonia gas as one of the products. Along with ammonia gas, you will get water and the respective salt containing the cation of the alkali. So, ammonium sulfate plus sodium hydroxide will give sodium sulfate, water, ammonia gas. Ammonium chloride plus sodium hydroxide will give sodium chloride, water and ammonia gas. Ammonium sulfate plus calcium hydroxide will give calcium sulfate, water and ammonia gas. So, these are the other equations to prepare ammonia gas by using any ammonium salt and a strong alkali. You can learn them up as well. But ammonium chloride and calcium hydroxide are the best reagents to prepare ammonia gas in the lab. Now, if you look at the ratio by weight, 2:3, the ratio by weight of calcium hydroxide is taken slightly higher just to compensate the loss of ammonium chloride by sublimation. Ammonium chloride is a sublimable substance. That is why, to prevent the loss of ammonium chloride by sublimation, the weight of calcium hydroxide taken is slightly higher. It is 2:3 by weight. Now moreover, we can also prepare this ammonia gas from metal nitrides, as you can see over here. Magnesium nitride, it is reacted with warm water, not steam, it is warm water, when magnesium hydroxide and ammonia gas is formed. Similarly, aluminum nitride, it is treated with warm water to prepare aluminum hydroxide and ammonia gas. Now, this method of preparation of ammonia gas from metal nitrides, it is quite expensive. It is expensive. That is why We do not use metal nitrides to prepare ammonia gas. Okay. Now, as I have discussed in the lesson of this chapter, study of compounds ammonia, I have given this lab preparation of ammonia from ammonium chloride. I have given you the physical properties. You can go to the physical properties. I have given you the uses. I have given you the chemical properties of ammonium chloride. But here, what you must keep in mind is ammonia gas. It is highly soluble in water. 1 volume of water can dissolve approximately 702 volumes of ammonia gas in it. It is highly soluble in water. Ammonia gas, as I have told you, it is an alkaline gas. It turns moist red litmus paper blue. Okay. Now, the next thing which I will be discussing is, in this chapter, the manufacture of ammonia gas by the Habers process. Okay, now we have, you can see on the board over there, manufacture of ammonia gas by the Habers process. In the manufacture of ammonia gas by the Habers process, the reactants are nitrogen gas and hydrogen gas. Nitrogen gas, 1 volume, it is mixed with 3 volumes of hydrogen gas, and it is sent into a chamber, catalytic chamber, where the temperature is maintained at 450 to 500 degrees Celsius. The catalytic chamber contains finely divided iron. This iron is finely divided. It is finely divided iron. It is finely divided iron which is acting as the catalyst, and there is a promoter also. The promoter is molybdenum, and the pressure inside the catalytic chamber is 200 to 900 atmospheric pressure. So, when these conditions are met, the catalyst, the temperature, the promoter, the pressure, then these 2 gases combine to prepare ammonia gas, twice NH3. Now, here you will see that nitrogen gas is taken as 1 volume, hydrogen gas is taken in 3 volumes. So 1 volume plus 3 volume, because of high pressure we get ammonia gas which is only 2 volumes. Now, this is how you manufacture ammonia gas by the Habers process. Now, you must remember one more thing over here, that they will ask you questions, from where do you obtain nitrogen? Nitrogen gas is obtained for this process by the fractional distillation. Fractional distillation of liquid air. Fractional distillation of liquid air, and this hydrogen is obtained from water gas by the Bosch process, BOSCH, Bosch process, which you have already learned in class 9. You must have learned about Bosch process in class 9. Okay. So this hydrogen gas for the Habers process is obtained from water gas. Water gas is nothing. It is what? It is a mixture of carbon monoxide and hydrogen, which is prepared by the Bosch process. So this hydrogen gas is obtained from the Bosch process. And this nitrogen gas for this Habers process is obtained from liquid air by its fractional distillation. So this is how you prepare, this is how you manufacture. When I say manufacture, it is always on a large scale. If you want to prepare ammonia gas on a large scale, you cannot prepare in the laboratory. You have to use very huge apparatus, huge equipments, so that you can prepare ammonia gas in large volumes. So that's why manufacture is always done by a process which is called Habers process. Now, my dear students, now we'll go to the next part of this chapter. There are physical properties, chemical properties, which I have already discussed in the lesson which I have sent to you in the WhatsApp group. Now, I would like to explain you quickly the study of compound, the next chapter, that is nitric acid. Now let me begin with the lab preparation of nitric acid. Okay, now as you can see on the board over there, study of compound nitric acid, the lab preparation is very, very important. Lab preparation of nitric acid. After hydrochloric acid, this is the second acid, which is a volatile acid. So for the lab preparation of nitric acid, potassium nitrate, sodium nitrate, chili saltpeter, Bengal saltpeter, potassium nitrate, sodium nitrate, any one of them can be used and reacted with concentrated sulfuric acid. Concentrated sulfuric acid, it is a non-volatile acid, and these two are heated at temperatures less than or equal to 200 degrees Celsius when potassium hydrogen sulfate, sodium hydrogen sulfate and nitric acid vapors are formed. This is the chemical equation which you must learn properly for the lab preparation of nitric acid. Now, if you look at the diagram over here, in the diagram there is a glass retort. This one is a glass retort. It is a glass retort in which we have placed either potassium nitrate or sodium nitrate over here at the bottom of this glass retort. From this opening over here, we add concentrated sulfuric acid. And then heat this glass retort from underneath to maintain the temperature less than or equal to 200 degrees Celsius. So when this temperature is met, then there is a reaction between common sulfuric acid and the potassium nitrate or sodium nitrate, and vapors of nitric acid is formed. The vapors of nitric acid move in this direction and then they enter this receiver over here. It is an empty round bottom flask which is fixed with the help of clamp stands, at the bottom over here, and then the vapors enter this flask over here, above which there is a tap containing, which is flowing cold water, very cold water to cool down this receiver. So when cold water is made to flow over this flask, the vapors of nitric acid, they condense and they collect as nitric acid, as liquid nitric acid. Now, my dear students, it is very important to understand that since there is some temperature less than or equal to 200 degrees Celsius happening in this lab method of preparation of nitric acid, this nitric acid may be slightly yellowish brown. The reason is, at such high temperature, nitric acid, it undergoes decomposition reaction. It undergoes decomposition reaction to form water, nitrogen dioxide and oxygen gas. This nitrogen dioxide which is formed, which dissolves in the nitric acid which is formed, to give it a slightly yellowish brown color. Now, how to remove the yellowish brown color of the nitric acid? We can either bubble air through it, or add tap water and stir it properly. The color becomes colorless. Nitric acid, you must keep in mind, it is a volatile acid. So this is how you prepare nitric acid in the lab. The diagram is important. Now, in the previous chapter, study of compounds, ammonia, ammonia, I have given you one equation where there is catalytic oxidation of ammonia. In the catalytic oxidation of ammonia, I have also discussed that there is an equation like this: NH3 plus O2. The catalyst is platinum. Temperature is around say 800 degrees Celsius. Okay. So when ammonia gas is subjected to catalytic oxidation, then it forms nitric oxide plus water vapor. The equation has to be balanced: 4, 5, 4 and 6. So this equation which you see over here for the catalytic oxidation of ammonia is a very, very important equation where a very important product which is called nitric oxide is formed. This important product, nitric oxide, which is formed, it is used in the manufacture process for the manufacture of nitric acid by the name of the process which is called Ostwalds process. Which is called what? Ostwalds. It is called Ostwalds process, which I will be discussing the next thing in this chapter. So now I will discuss the Ostwalds process, the next thing in this chapter, my dear students. Have a look now. Okay, now my dear students, you can see on the board, manufacture of nitric acid by the Ostwalds process. This Ostwalds process, it takes place in 3 steps. The first step of the Ostwalds process is catalytic oxidation of ammonia. In this reaction, 1 volume of ammonia, it is mixed with 10 volumes of air. 10 volumes of air, out of which only oxygen is used to react with ammonia gas, 1 volume of ammonia gas. In the catalytic chamber, catalytic converter, the catalyst is either platinum or vanadium pentoxide, and the temperature maintained is 800 degrees Celsius when nitric oxide and water vapor is formed. That is in the first step, in the catalytic converter. Now, the gas nitrogen monoxide is separated from the water vapor and it is cooled down. The gases are sent to a cooling pipes where the temperature is lowered from 800 to 50 degrees Celsius, and in this oxidizing chamber, oxygen is still there because we have taken 10 volumes of air. So in the oxidizing chamber, Nitrogen monoxide, it is combining with oxygen gas to form reddish brown colored nitrogen dioxide gas. Now, once the nitrogen dioxide gas is formed in the oxidizing chamber, it is now sent to a tower which is called absorption tower, which is packed with quartz stone, where it combines with water and then oxygen to form nitric acid. And the nitric acid which is obtained over here, it is of concentration 68%. So this is what you must remember from the Australis process for the manufacture of nitric acid by this method. Okay, now I'll be discussing about this chapter nitric acid in the lesson assignment, which I'll send you after some time. You must go through the nitric acid chapter properly regarding its physical properties, chemical properties, the uses of nitric acid and more other things, and then I'll be discussing the question answers also. The next chapter which I'll be doing will be study of compound sulfuric acid, which is the last part of this chapter. Thank you so much. Have a nice day.